So in this video I'm going to show you how to draw the tangent line. So this is our tangent line, and I'm going to show you how to draw the normal line. So this is our normal line for a given curve. So for this given curve, x squared plus x. So as I press play, it will automatically draw the tangent line and the normal line. Okay, so so hang on, let's pause this and jump to here. So in this video, for a given curve, this curve here, given by this equation, we're going to come up with the tangent line, and then later on I will show you how to get the normal line, which will be at 90 degrees. So first step is to come up with the equation for the tangent line. Well, the tangent line will be a straight line, so we know it's going to be of the form y equals mx plus c. So our job is to work out the gradient right here. So this is A, and this point here, the coordinates of this point will be a comma a squared plus a. Okay, so so now we need to come up with the gradient. Well, to work out the gradient, you need to differentiate this. So dy by dx equals, or differentiate this would be 2x, differentiate this would be 1. So that's our gradient for anywhere along the curve, but we want the gradient right at x equals a. So we would put a inside here. So the gradient at this point here will be 2a plus 1. So the gradient here will be 2a plus 1. That's our gradient. That's just the m part. But the equation of the line requires the x. So it will be x plus c. We need to work out c now. We need to work out the intercept. See the tangent line here? We need to work out c. C is right here, the intercept. So we've got to work out c. So to find a particular point on to find the intercept, we need one particular point on this tangent line. Well, we know the coordinates here. The coordinates here will be a comma a squared plus a. So this is your x location, this is your y location. So put this into the y, put this into the x, and then work backwards to find c. So let's put this into the y. So that would then be a squared plus a, and then put this into the x. So that would then be 2a plus 1 a, because you would put the a into the x, and then plus c. So now it's just a matter of working out c. Let's just multiply this out. So this would be 2a squared, this would be plus a, and then you've got your plus c at the end, and then over here you've got this thing here. So now these two cancel each other out, and then take away 2a from both, 2a squared from both sides. So that would then give you a minus a squared and c. So so now we've got our c. So this point here, this is our intercept here. It's actually minus a squared. That's our intercept. Now that we've got our intercept, we can put it back into here. So our final equation for the tangent line would be given by this: 2a plus 1x, and then, well, we've got to put this into the c. We now know the intercept, so that would be plus minus a squared. So this is the equation of our tangent line. So now let's put it into Desmos. So jump to Desmos. Let's start with a blank graph. So start out by drawing in our curve. So that would be x squared plus x. So that's our curve. Now we need to insert a particular point on that curve. So bracket a comma a squared plus a, close it off, and then add our slider. Let's just limit it from -2 to 1. So now press play, so you can see the dot, a particular point on that line moves around like this. So now we need to punch in our equation of the tangent line. So our tangent line was given by this. This here, hang on, this here is our tangent line. So we just need to punch that in. So that would be 2a plus 1, hang on. So that would be bracket 2a plus 1 close bracket x minus a squared. So that's our tangent line. So press play. So now we've got our tangent line. Now we need to come up with the equation for our normal line. So hang on. So far, hang on. So far we've got the equation for our tangent line. So hang on. We've got the equation for our tangent line, which is given by this. Now to come up with the equation for our normal line, well, our normal line is a straight line, so it's going to be of the form y equals mx plus c. We need to work out this gradient. So remember, if you want, with the tangent line, we know the gradient here. The gradient is given by this. If you want something at 90 degrees to that gradient, you would take the negative reciprocal of this thing here. And I've already explained why in the past. So if you want something at 90 degrees, take the negative reciprocal of this. So so the negative reciprocal of that would be, well, the reciprocal of that would be 1 over 2a plus 1. But then you want the negative version, so stick a negative in there. So this m here, the gradient of our normal line would be given by negative 1 over 2a plus 1, and then you've got your x here, and then plus c, and then y. So now this normal line is given by this, but we still need to work out the intercept. So we know to work out the intercept, we need one particular point on that line. Well, we've got one particular point here, and the coordinates of that particular point are given by is given by x. And then this thing here is your y. So let's put this into the y. So that would be a squared plus a equals, and then put this into the x. Let's just multiply it to the top. So that would be minus a over 2a plus 1 plus c. So now it's just a matter of getting c on its own, because this c here represents this point here. We need to work that out. So take away this, sorry, in your mind add this block to both sides. So the intercept is given by a squared plus a, and then add that block, a over 2a plus 1. So now we've got our intercept. We can now put this whole block here is our intercept. So we can now put that into here. So our final equation would be given by y equals negative, I'm just going to multiply this x to the top. So that would be negative x over 2a plus 1, and then you've got your plus c. Well, our c is this complicated block here. So that would be a squared plus a, and then plus a over 2a plus 1. So this is the equation of our normal line. So let's punch this into Desmos. So jump back to Desmos and punch that in. So it was, what was it? It's negative x over 2a plus 1. So it's negative x over 2a plus 1, and then it was hang on, let me jump back to here. A squared plus a, so a squared plus a, so it's a squared plus a, and then it was plus a over what? A over 2a plus 1. Hang on, 2a plus 1. 2a plus 1. So that's our normal line. So now you can slide this back and forth, and then it will draw your tangent line, and your normal line. Okay, so the final answer, and let me clear everything here. So the final answer is hang on. So our tangent line is given by. So our tangent line is given by. Hang on. So our tangent line is given by this, and our normal line is given by this. Okay.